Have you ever wondered how your phone just knows which way is up? Or how a car's airbag can possibly deploy in the blink of an eye? Well, the answer isn't magic. It's actually a hidden world of microscopic technology and I mean this literally, all around us. So today, we're going to pull back the curtain on these tiny, invisible powerhouses. Okay, just look at this. That little speck right there on the fingertip, yeah, the one smaller than a grain of rice, that's not just a tiny piece of silicon. That is a complete, super sophisticated sensor system. And that big disk in the background, that's the silicon wafer it was sliced from, holding hundreds, maybe thousands of identical copies. This incredible miniaturization, this is the key to everything. So let's get right into it. What exactly are these tiny marvels? To really get what makes them so special, let's just break down the name itself. The name pretty much says it all. MEMS stands for Microelectromechanical. You've got micro, because they're microscopic. You've got mechanical, because there are actual moving parts. And then you've got electro, because it's all combined with sensors and electronics, all built together on one single tiny chip. It's like shrinking an entire factory down to the size of a speck of dust. So what do they actually do? Well, at their core, they do what all sensors do, right? They measure something out in the real world, like, say, the acceleration of your phone when you turn it or the pressure in your car's tires, and then they convert that measurement into an electrical signal that a computer can actually understand and use. Okay, so that's the what, but how on earth does something so incredibly small actually work? To find out, let's zoom way in and take a look at a classic example, a MEMS pressure sensor. Now, what's so cool about this diagram is just how simple and elegant the design is. You've basically got two main parts, a flexible top layer, that's the diaphragm, and a fixed bottom layer, the backplate. The real secret sauce to the whole thing, though, is that tiny, perfectly controlled air gap that's sitting between them. Here's a great way to think about it. Just picture that diaphragm as a microscopic drum skin. You know, when you apply pressure to a drum, the skin flexes and moves. It's the exact same principle here, just happening on a scale that is, frankly, mind-bogglingly small. So here's how it all comes together in 3 simple steps. First, some external pressure pushes down on our tiny drum skin. Second, that diaphragm bends, which makes it get closer to the backplate, shrinking that all-important air gap. And third, the sensor's electronics measure that tiny change in distance as a change in electrical capacitance, which, is really just a fancy way of saying its ability to store an electric charge. That change is the signal. It's simple, it's elegant, and it's incredibly effective. And here it is, the real deal. We go from that clean, simple drawing to an actual image from a scanning electron microscope, and you can really see the incredible precision we're talking about. The perfect square shape, the layered structure, even those tiny holes in the diaphragm to control airflow, it's an absolute masterpiece of microengineering. Seeing one is amazing, for sure. But the true revolution isn't just that we can make one, it's how we make them. And that brings us to the real magic, the manufacturing. This right here is the total game changer. MEMS sensors aren't built one by some person in a tiny lab. Nope, they're made using the same techniques we use for computer chips, basically printed onto these big silicon wafers. We're talking millions of them all at once. The scale is just staggering. And this process, called batch fabrication, has some huge advantages. For one, it makes the cost for each sensor incredibly low. We're talking pennies sometimes. It lets us mass produce them to meet insane global demand. It means every single sensor performs with amazing consistency. And maybe most importantly, it allows them to be built right alongside the electronics that read their signals, all on the very same chip. So, when you have these sensors that are this small, this cheap, and this effective, where do they all end up? You might be surprised to find out that the answer is, well, pretty much everywhere. That phone in your pocket? Oh yeah, it's packed with MEMS accelerometers that detect motion so your screen can rotate. Your car? It absolutely relies on them for critical safety systems like airbags and stability control. That fitness tracker on your wrist is counting your steps right now thanks to a MEMS sensor. The entire world of the Internet of Things, from smart homes to intelligent cities, it's all built on a foundation of these tiny, powerful little devices. Okay, so they're in everything. Big deal, right? Well, yeah, it's a huge deal. Let's pull back and look at the big picture for a second. Why is this tiny tech so incredibly important?
It really boils down to this simple but really powerful equation. You take the ability to make sensors incredibly small, that's miniaturization, and you combine them directly with electronics on a single chip, that's integration. That combination, that is the engine of modern innovation. It's what has unlocked countless technologies that we all just take for granted today.
And that leaves us with a really fascinating final thought to chew on. We've basically mastered the art of creating microscopic sensors and scattering them all throughout our world. And the technology is only going to get better. Smaller, cheaper, more powerful. So the real question for the future isn't if we can measure something, but what on earth will we choose to measure next?